Okay, why don't we get started? So I'm excited about this presentation, so I'm ready to jump right in. So my name is Kevin Bjorne, and I'm the technical director here at IRIS. And today I'm going to be joined by Natsuko Nicholls, the research manager here at IRIS as well. And we are going to talk to you about using IRIS data for institutional research purposes. Go ahead to the next slide. So what we're going to talk about today, first, we're going to talk just briefly a little bit about what is IRIS. This is for many of the people participating today that are not IRIS members, or who perhaps are individuals from IRIS member universities that just aren't familiar with what we do. And then once we cover that, we're going to talk a little bit about the data that is available inside what we call the virtual data environment. This is the data that institutional researchers will have access to run their own queries and answer their own questions. Then I'm going to hand off to Natsuko, and she will talk to you about how you gain access to the data set. So there is a process that needs to be followed to request access, to get the right permission, and then to actually log into the enclave and do any kind of work that you're interested in doing. After that, we're going to jump into a live demo. So when she hands back to me, I'm going to actually take you into the enclave. I have some queries ready to go. It's going to crunch some numbers. I'm going to talk to you about what you can do with the data. And it's just going to be a really tight overview of what's available to you inside the IRIS enclave. And then we're going to finish up with any questions that you might have. Now, throughout the presentation here, if you do have questions, feel free to use the Q&A function of Zoom or the chat function. Either of those work fine. Another IRIS staff member here, Dan Meisler, will be monitoring that, and he'll communicate questions to us as they come up. And then also something to keep in mind as we go through this, and by the end of it, if you are interested in talking more about your specific needs and whether or not they can be met with this type of tools and data that IRIS maintains, just let us know and we can have a private conversation outside of this meeting. And if you are an IRIS member, then we can actually do demonstrations with your actual data. So again, we can talk about that at the end here. And at any time, feel free to share your thoughts or questions with us. Okay, so let's talk a little bit about what is IRIS. So IRIS is an organization that was founded in 2015. It is based at the University of Michigan, and it is formed around an IRB-approved data repository. The purpose of IRIS is to help universities understand, explain, and improve the public value of the academic research that they conduct on their campuses. So what does that mean? That basically means we all are at universities where research is taking place, and the ability for us to communicate the value of that research, particularly to the public, is the primary mission here at IRIS. And so what we do is we collect data from our member universities. We collect administrative data. So this is the data that's used on a day-to-day basis for the running of a university. So this would include procurement data, employment data, sponsored projects data. We collect this data at a transactional level, so a day-to-day set of transactions that flow into IRIS from our member universities. And we combine that data across all member universities. So there's a lot of cleaning and normalization that takes place. And we then link that data to a variety of different external data sources that we bring into IRIS. These data sources include data from places like the US Census Bureau, private sector entities like Bureau Van Dyke, which provides business data, and it's a subsidiary of Moody's. Stepping Blocks data, which is data about people and their outcomes. Public federal sources, so this would be things like NIH Reporter and NSF and other federal award areas, and other private sector sources. So the data that we bring in and work with is focused exclusively on the research enterprise that's taking place on all of our campuses. That's our focus. We want to help university members explain and understand the value of the research that they're conducting. So when we talk about students, we're talking about students who are funded on research projects, who are working on those research projects. When we talk about faculty, staff, and others, it's always in the context of the research enterprise that's being conducted on our campuses. Now, in terms of scope of data, we have data from 38 different universities, and these are typically the largest universities. So we have data from University of Michigan, most of the Big Ten schools, Johns Hopkins, so on and so forth across the country. And we take all that data and put it in one place. This data represents roughly 40% of all R&D spending that takes place in the nation. It also accounts for roughly 33% of all the doctorates that are granted here in the nation. Now, this is important because we have information on all of these people and we have information on all of these awards. The system, the tools that we're going to demonstrate here are part of something called the enclave, the data enclave, the secure data enclave, the virtual data environment. We have a variety of names for it, but ultimately what it means is it's a place where researchers can log into IRIS remotely, access the data to conduct research and answer questions that are pertinent to them. As you can see, we have roughly 360 researchers right now from across the country that are utilizing the IRIS data sets to answer a variety of questions. Okay, so that was just a brief overview of what is IRIS. So let's talk a little bit about the data, because I think that's why we're all here. So the data, like I said, is administrative data that flows in from our member universities. So basically, administrative data is covering three main areas. So there is the award data, there is spending data, and there is employment data. And so in terms of award data, we can see in this diagram here, money is awarded from the federal government and it flows into a university. That money is used in two ways. It's used in direct expenditures and indirect expenditures. In terms of direct expenditures, we look at things like the people who are being employed on these research awards. These are people who are receiving some sort of salary from the work that they do, furthering whatever the research projects that they're working on. Then we also pull in data about the goods and services that are being purchased to conduct that data. So these would be things like computers and microscopes and travel and things like that. Anything that is used to further the research projects. Additionally, we pull in data on subawards or subcontracts that are typically made when a university subcontracts out a portion of the research to another organization, usually another university. And we're able to track all of that information for every member university of IRIS. And so it allows us to do a couple different things. We take that data and then, like we said earlier, we merge it with other data sets, which then allow us to expand the value of that data and derive a wide range of metrics and reports for our members. Go ahead, next slide. So just a quick overview of some of the basic statistics of the data that we have. So in our most recent data release, we have data that represents roughly 99 billion, let's say 100 billion in award spending, almost 500,000 funded awards at 33 IRIS member universities. And since then, we've added a lot more universities. So the next data release will have more than that. Number of payments to almost 1 million vendors, 900,000 different vendors across the country, 900,000 different businesses across the country, and information on almost 750,000 employees that work at these universities at various points in time, at various levels, undergrads, grad students, faculty, staff like myself, postdocs, so on and so forth. All of that information is available in our data release, and this is the administrative component of the data. So this right here is a basic overview of the data sets that we make available inside the enclave. So there is what we call the core collection, which covers the administrative data that I just mentioned, award data, employment data, vendor and subaward data. And keep in mind, this is all for the research enterprise that's taking place on your campus. So for example, we have student data, but it's only for students that have been identified as having worked on research projects at your university, so not all students. We have an auxiliary data collection, which is object code definition. So these would be accounting codes that are used in the other files to help you understand what types of purchases are being made. Are they capital purchases? Are they travel purchases? Are they, computer purchases, things like that. It provides background information, sub-organizational information from our member universities. So this helps you understand what units on campus are receiving the funded awards. So is it a particular school, a particular department? You can pull all that information in. Federal information like CFDA, these are the funding agencies that are providing the funding for all of these awards, and employee demographics such as age, gender, so on and so forth. Other things that we link to, so we have award linkage information, agency award data. So agency award data would be award data pulled from NSF, NIH, USDA, NASA, DOD, places like that. We pull that in, link it to the award data that's submitted by our members, and that way you can understand maybe abstract information. You can do topic modeling. You can do all kinds of different things with that. We do link to publications. So just an example, Web of Science, things like that. You can pull that information in and do analysis on publications, which is one of the things that we do here at IRIS. We also have availability to stepping blocks, education and employment data. And this is information about people who have worked on research projects at your university. And in terms of education, we can tell you where they got their bachelor's, master's, PhD, when they did it, things like that. And in terms of employment information, we can tell you about where they went after they left your university, how much they earn, what kind of jobs they're doing, things like that. Bureau Van Dyke has business information. So if you were doing any kind of analysis, economic analysis on the spending that takes place when you're conducting research, you could pull information on businesses. We provide you with all the IDs that are available. And then assuming your university has a Bureau Van Dyke contract, which many of us do, you can take that and pull all the data that you want related to that particular business and merge it in with whatever you're trying to understand. And so this is an overview of what's available, and it's always growing. We're adding more and more data all the time.
Hey, Kevin, let me just ask you a quick question that came up.
Yes.
When you mentioned the 40% of federal R&D spending, is that all federal spending or just higher ed?
It is just higher ed. So I'm pulling that information out of the HERD survey. And so we pull that, we basically look at how much money all the IRIS members are receiving, and we compare it against what's in the HERD survey, and that's how we derive that percentage.
Okay. And there's another question about access to and who gets access to what, but we're going to touch on that in a few minutes, right?
Yep, that'll be coming up next. Natsuko will talk about who can gain access to this data and how you do it.
All right, thanks.
Yep. So one of the things that IRIS does, its core process in terms of providing information back to our member universities, is that we produce reports. We take all of this data, we derive metrics from it, and we produce reports that are fed back to our member universities that cover a wide range of topics, from the impact of people to the economic impact of your research across the country, within your home state, within your local area. There's a variety of government relations reports that we produce. We have vendor data, vendor reporting that tells you about your relationships with small businesses, minority and woman-owned businesses, and the impact there. We talk about team science and who makes up these research teams that are doing all the work. And we look at success metrics for faculty and others that are working towards different goals at your universities. And we produce these reports and feed them back to your communications people, your government relations people, your offices of research, and anyone else on your campus that's interested in receiving them. Okay, so this presentation is all about the data that's available and institutional uses that we've been able to come up with. But I want to stress that this is just sort of the tip of the iceberg of what you can do with this data. One of the big things that excites me is the ability to do benchmarking. So you can, with this data, produce benchmarking metrics to compare your institution against an aggregate of universities that are IRIS members. So for example, if you wanted to produce some sort of student benchmarking metrics, again, related to research participation, you could benchmark your university against the Big Ten, or against all private universities, or all publics, or land-grant universities. So you can define peer groups that you would compare your university to and derive meaningful metrics. And so, you know, the usefulness of this data is based on whatever the priorities are for your university. Today, in the examples that I'm going to be sharing with you, they're all very student-centric. And the reason I'm leaning that way is because prior to coming to IRIS, I was the director of institutional research at a smaller university. And so I have always been interested in students, their outcomes and things like that. So we're going to talk a little bit about that in the examples, but that is just a, you know, again, like I said, tip of the iceberg of what you can do with this data. You can analyze economic impact. So one of the things that we do frequently is provide economic impact indicators for particular geographic regions of the country for government relation purposes. We also provide data that is relevant to, you know, legislators, that is relevant to internal measurements as far as impact goes. And one of the things that that really excites me is when IRIS data is used for advocacy, which it has been done quite frequently in the past, both at the federal and state levels. And so these are just a handful of the things that you can do with this. And one thing I want to stress, if you have ideas and you're not sure if it can be accomplished with IRIS data, ask us, shoot us an email, and we'll tell you, that's a great idea. Yes, you could certainly do that. And a lot of times we might even help you do it if we have the bandwidth to provide some support like that. Okay, so how can you access the data set? I'm going to hand off to Natsuko here, and she can talk a little bit about how you gain access to the data set.
Okay, I'm Natsuko Nicholls, Research Manager at IRIS. Today, I will briefly explain how we share the restricted access data and how you can gain data access. So what is the first step? data access request starts with the online application available from our website. The application form in PDF is also downloadable from the website. The link is listed on the slide. We ask you to tell us about you, your collaborators, if any, goals and expected outcome of your project. Another important piece of paperwork is the Restricted Data Use Agreement. RDUA is an institutional agreement and it needs to be signed by institutional officials at your institution at the University of Michigan. The need of RDUA makes the process quite formal and time-consuming. However, this is very important because we promise our member universities, our data providers, that we protect the privacy and confidentiality of the individuals represented within the data set, as well as the identity of the institutions themselves to the greatest extent possible. Is there any fee involved for data access? Well, yes and no. If you're affiliated with one of our IRIS member universities, you don't have to worry about seat fees. If not, seat fees are charged annually. A final step is to view a short online tutorial video that covers subject of data security and rules when working in the secure virtual data enclave. At the end of the video, you are asked to read and sign the IRIS Virtual Data Enclave Acceptable Use Policy. This is basically about a do's and don'ts when you are working with our data set. For instance, we ask users not to take any screenshots of displayed data. Now, I'd like to add a little more information that helps you start thinking about proposing your project using our data set. Let me ask you if your project is for scientific research or is it related to known research activities? Well, first of all, what is research and what is known research use? Research is a systematic investigation, including development of research questions, hypothesis testing, and scientific method to draw conclusions. It is designed to develop or contribute to generalizable knowledge. Findings are usually published in scholarly journals. Known research work includes assessment activities and a program evaluation. Outcomes are usually presented in practice guidelines, white papers, organization position statement, and so on. With this distinction in mind, we usually direct users to either of the two types of data set. Essentially, the data structure and contents are the same, but the biggest difference is that one is de-identified and the other is identified. For research purposes, we definitely recommend the first options, through which you get to access the de-identified data from all universities. In the forthcoming Release 22, we include the data from 34 universities. In using the de-identified data of all universities, if your institution is a member of IRIS, we can tell you which de-identified university ID is your institution. This enables benchmarking against peers. In the first part of the demo, Kevin will show an example of benchmarking using the de-identified release dataset in the scenario that your institution is a member university. The second option is to access the identified data, but it is the data of your own institution that is a member of IRIS. In addition to the usual data access application process that I mentioned earlier, you also need to reach out to the Office of Research Administration office at the institution for permission to access identified data. In the second half of today's demo, Kevin will demonstrate the use case of a single university data and the linkage product. Well, once you're granted access, you'll be excited and you'll be working with our data set in the environment called Virtual Data Enclave, or we call VDE. It is a virtual machine launched from a user's own desktop, but operating on a remote server protected by a variety of firewalls. and security protocols. We currently have 16 remote workstations plus a terminal server in which more than 20 active users can access and work with the data simultaneously. We use a terminal server for data training and workshop. In this working environment, you are without internet access, and most importantly, under a particular restriction of file transfers between the enclave and outside of it. For file transfer, we ask users to fill out the data import or export request forms. The information you provide in the form helps us understand how you generate your output, such as frequency tabulations or regression coefficients. It also helps us effectively and efficiently review your files to be brought into or taken out of the VDE. We ask 4 to 5 business days for this review process. While preparing your output for review, it is important for you to remember that any cell count less than 10 will be asked to mask for protecting privacy and confidentiality, regardless of you're working with de-identified or identified data. Okay, this is all I have regarding data access. And let us get into a more exciting part of today's webinar, live demo. So back to Kevin.
Let me interject here with a couple of questions. I think you answered this one, Natsuko, but there's a question: do members have access to the data at the same level as collected by U of M?
So yeah, I'll answer that. So members will have access to the de-identified data set. So that would give them access to peer universities' data in which they could do benchmarking, but they will also have access to their fully identified data set. So that would include things that have PII and things like that. And also the linkages associated with that for their university only. They cannot see the identified data for any other IRIS member university.
Okay, a couple more questions, I think, before we get into the demo.
Okay.
One is pretty quick. How is the demographic data derived?
So the demographic data is derived from 2 sources. One is imputed, and the other one is from stepping blocks. So we take the data from both sources and apply it to our data sets. I think Natsuko could talk a little bit about like imputed gender and stuff and how accurate we've been able to get it. And then of course, there would be separate gender measurements that would be available through the stepping blocks data. But again, that would only be available through the identified linked data sets for your university.
Okay. We have one more question about units of investigation, departments versus colleges, et cetera. But I think we should save that for afterwards. So,
okay. Okay, and I saw something else there about how are peer groups defined?
Right.
Right. So to answer that one really quick, guess what? You get to define your peer group. So we do have what we call institutional fast facts that identify high-level groupings of universities. So all the public universities would have a flag that would let you pull, call them a peer group. All the private universities, all the universities with medical schools, universities that are land grants. But you can define your own peer group. So if there was a specific group of universities that you wanted to compare yourself against that are IRIS members, the only requirement is that you have at least 3 of them in a peer group to, again, protect privacy and data integrity. Okay, is that the end of the questions for now? Okay, great. So actually, Natsuko, can you throw that slide back up there really quick? Okay, so what I'm going to do now is take you into the enclave, and I'm just going to show you just a few of the queries that we've put together for this demonstration that just scratch the surface of what you can do. So the first thing that I'm going to do is demonstrate one use case for benchmarking. And everything that we do is going to be very student focused for this demonstration, but there is no reason why you would have to limit it to just students. You could focus on whatever group of researchers that you would be in, that you're particularly interested in, that is your priority. So the first one is going to look at universities' ability to compare their relative strength at supporting students that are involved in research. This is where we'll compare a single university against two different peer groups and look at the numbers of students that are supported by their research. Additionally, then we're going to look at the education paths of students. So this would utilize the fully identified data set. And again, we've aggregated it here for this presentation to preserve privacy. But what we're going to be looking at is students that worked on research at your university and then left the university to get additional education, higher education at other universities. And then we're going to look at the career paths of these students. Where do they go once they leave a university and they start working in the private or public sector? Where are they living? How much are they earning? What kind of businesses are they working for? That kind of stuff. So again, these are just sort of some high-level examples of what you can do. One of the things, if you're interested, is that we can provide you with a data dictionary that shows you which fields are available in the data set. And again, anytime you have questions or you want to talk about this or you're unsure of something, contact us, email us, call us, whatever it takes. We want you to use this tool and we want you to use the data set. Okay, go ahead and you can stop sharing, Natsuko, and I'll take over here. Okay, is everybody able to see the data?
Yes.
Awesome. Okay, so don't panic. We see code. So I know not all of you are coders and you're not expected to be. When I envision a lot of this stuff, I envision somebody with a business intelligence background, data analytics background, information science, something like that. These are the people who would typically be coming in to work in the enclave and build the queries and programs necessary to answer whatever the questions are that are relevant to you. In the enclave, we have a variety of tools that are available. So what I'm using here today is pure SQL. I'm keeping it simple, but we do have tools that let you work in Python, Jupyter Notebooks, SAS, if you're so inclined, SPSS, and other things. So whatever tool you're comfortable with, or whatever tool your business analyst or data analyst is comfortable with, will be available for them inside the enclave. So what I'm going to show you here, this first result chart, is simple benchmarking. So what I've done here is, using the data available through IRIS, I've created a very simple benchmark chart here that shows federal funding sources on the left-hand side and the number of students that their research dollars are supporting at universities. So in this second column here where it says university student count, these are the number of students that are being supported by funding, research funding from these different federal agencies. Now, again, I've capped it at the top 11, and there are far more funding agencies than I'm showing here. And also, I'm only focusing on federal funders. We have this exact same data available on non-federal funders. So if you're interested on, something similar, students who are funded by the Bill and Melinda Gates Foundation, you could run the exact same kind of code to find that out. Now, I've created two very high level, actually not me, Natsuko created two very high level peer groups here. So all public universities that are members of IRIS and all private universities that are members at IRIS, and counted the number of students on average that are supported by the exact same federal agencies in those peer groups. And so what we see here is in University A, and this is just a random university that I chose, Health and Human Services supports 3,042 students. So if you were to dig into that data more deeply, and again, there's a lot more underlying data below this chart, you would find that the majority of that is coming probably from the National Institute of Health. And you could also probably surmise that this university has a medical school, which is why that number is so much larger than the average at these other two peer groups that we're presenting here. Now, interestingly, if you go down to the Department of Education, we see that the peer groups support on average more students than at the target university that I'm working on here. And then if you go further down the list, the numbers drop off, and where we have the null values, those numbers fall below 10 students. So again, for this presentation in particular, we're masking those values to preserve privacy protection. But if you were working inside the enclave, you'd be able to look at that. Now, you would not necessarily be able to pull them out of the enclave to use in a publication or something like that. We would ask you to mask those before it comes out. But so long as you're working in, you could actually see the numbers that would be there. So this right here is just a very simple example of very basic benchmarking. You could benchmark a wide range of different things. So in this case right here, my thinking was that, you know, you're just comparing the relative strength that your university has in supporting students that are involved in research. You could, you know, benchmark grad students or undergrad students. You could further refine the categories here. We have job titles, we have occupations, we have full-time, part-time. You could also look at gender breakdowns. You could look at females versus males in these different categories. So there's a wide range of ways that you could provide different types of benchmarking in this. And so this right here is an example of the internal processes of research, right? We're looking at funding sources and the people who are being hired or who are working on these research projects. You could refine this. You could look at just medical research, or you could look at social science research. I mean, you can apply however many filters to this as you see fit. And at any time, if you had questions and you wanted to talk to IRIS people, you just have to email us. We'd love to help with this kind of stuff. So I know this can be a little overwhelming when you look at it, and especially if you dig into the data, but we're there to help you and hold your hand so you don't need to worry about that kind of stuff. Okay, so any questions about this one use case before I jump into some other ones? No, okay.
One
Oh,
question.
go ahead.
Oh, actually, maybe we should wait on it. Let's wait on it. You just go on to the next.
Okay. All right. So one of the distinctions here that I mentioned just before jumping in is this query and this set of metrics is utilizing the de-identified data set that we have, which allows you to compare your university to other universities. Now, this next one that I'm going to share with you is all about educational trajectory. And so this is using the identified data set. So in this case, you would only be able to derive these types of metrics from your single university. We would not provide it for the other universities because people have to be identified to do this, because people are linked to stepping blocks data, which is the person level data that provides information on their educational history, on their career paths, earnings, things like that. So again, this is an extremely high level query that I've built here. And the chart basically is, we have a university, and I figured, let's look at who's getting bachelor's degrees. How many people are getting bachelor's degrees at this university? And this is the start of a two-step process here. So I'm looking at everyone at University A, who has received a bachelor's degree, and I'm looking at how long it took them. So I know a lot of our universities, members and non-members alike, have internal data that lets you, calculate this kind of stuff already. So I just wanted to show this here because this is the foundation for the next one that I'm going to share with you. So you can see here, most people get their degree in 4 years. Some take longer, some do it quicker. And then we get into the next more important one here. So I'm going to run this query. And now what we're going to look at is, of that group of students who got bachelor's degrees at our university, how many of them went on to get higher degrees, higher levels of education? And so I wrote a query that looks at all the data and identifies those students that got doctorates or masters. And more specifically, where did they go to get them? So we actually have the person level data, so you could know what universities they go to get these degrees, and you can actually know what kind of degree they get. I've filtered that out and aggregated it up here. So we can see, of that group of bachelor's students, and remember, these are bachelor's students who worked on research projects, funded research projects at a university, how many of them went on to get doctorate degrees? And specifically, how many of them got doctorates at the same university where they got their bachelor's? How many of them got doctorates in the same state that University A is in? And how many of them got doctorates outside of that state? You could break this down any way that you want. You could add in genders, you could add in specific types of degrees. We have all of that information available. And so one of the stories that you could say here is, roughly 30% of the students stay in the same state where they got their bachelor's degree to get their doctorate. So one of the things that we talk about here sometimes is the brain drain versus brain gain scenario. How many students are leaving a state, a geographic region, and how many students are coming to that same geographic region. And so this is the start of a very high level look at that. And again, you could take this into 100 different directions with the data that's available. And if you're unsure of the data that's available, we have data dictionaries, and you can always talk to us. So from that same set of bachelor's students that worked on research projects, so these were undergrads that were working on research projects at this university, these are the numbers of students that went on to get master's degrees, again, out of state, in state, and at the university itself. So this is just one example of how we could use person level data to derive metrics related to student educational trajectories. The next query that we're going to look at is all about where people go and what industries they find employment and how much they earn. So right now, let me expand this. So basically what I did here is, using the linked stepping blocks data, I am able to determine when someone leaves a university, your university, in this case, the example university that I'm using, where do they go? Where do they move to? What kind of jobs are they getting? How much are they earning? And how long have they been in that job? And so in the data set that I'm using here, and I've aggregated it out, but we have their job titles. We know what kind of work they're doing. We know specifically what businesses they're working for. So who works for Google, who works for Facebook, who works for a foundry someplace. We have that data. We know how much they're earning. And the state codes over on the left-hand side tell us where they move to. And we actually have that information down to a much finer grain, but I've aggregated it up to the state level. So these state codes here, if you're not familiar with FIPS codes, I don't have the state abbreviation, but I can tell you that state number 6 is California. So what we're looking at here are, again, students who participated on research at the example university, left the university and went to California. And when they went to California, they found jobs. And so let's look specifically at grad students. So grad students would be anyone who was pursuing a master's degree or a PhD at the university. And again, you could cross-reference this with the educational data that I showed in the previous query. So you could, refine this a lot more precisely than what I'm doing here. And of these grad students, let's look at ones that go into a particular industry. So I'm going to do, let's see here, information technology. Now, the underlying data that we have for this would actually tell you what companies in the industry of information technology these graduate students are working in. So you could, in principle, talk a little bit about your university's relationship with hiring or funding from particular industry leaders. For example, let's say you're interested in the automotive industry and you want to know, how much money is Toyota funding and research at our university? You could learn that here. And how many people from our university are going to work for Toyota after working on research projects that were funded by Toyota? You could learn that here. So in this high-level example, we can see that 60 females and 190 males that, again, participated in research at this university went on to find employment in the information technology sector in the state of California. And then we can look at their earnings here. So on the lower end, this is what they're earning. This is their median income, and this is the upper income right here for people that find employment in this particular industry. So in these examples, let's take a look at automotive. I'm curious. Oh, nobody, I guess. Let's see here. Let's look at engineering. Let's do all. And let's do at the national level. So state code 00 is the entire nation. So this aggregation is people that go into engineering that started out at the university with these different employment classifications. So let's just look at grad students again and go on to find employment anywhere in the country and how much they earn. So you can again see 20 females, 50 males. Now, these numbers seem low, but you have to remember this isn't the entire student body that we're looking at. This is a subset of the student body at this university. So we're only looking at those that received some sort of funding and worked on some sort of research project at the university. And then what happened to them after that. Now, you could do some interesting comparisons. If you had other earnings data for non-research students, you could do a comparison and see, does working on research change the career trajectories of individuals? That would be an interesting question to ask right there. So I know this was fast, and I know that this was very high level, but I wanted to just give you a taste of some of the things that you can do with this data once you get into the enclave. And again, we are here to help, and we want you to use this. So if you have ideas, by all means, talk to us, and we will help you make it happen.
So let me jump in here, Kevin, with a question
Sure.
or two. There were several questions about the employment data. I want to try to consolidate them into something that includes them all. First of all, where do we get the employment data? Talk a little bit more about stepping blocks, and does it include current jobs or also people's jobs history? And what's the coverage in terms of match rate, I guess?
Right.
And,
so, okay.
Yeah, there's a couple more. So,
okay. So employment data questions. So Stepping Blocks gets their data from a variety of sources. Part of it is publicly available data that they get from LinkedIn, Facebook, and other places. Part of it is from privately sourced data that they pay for, and then they aggregate or they combine it all together and provide it to us. So there's a wide range of inputs there that go into their data. I will say that we vetted their data against census data inside the Census Bureau, and it came back very, very, very close. I mean, I think they were within a few percentage points of each other. So we feel very confident in the quality of the stepping blocks data. Additionally, then, what was some of the other questions? I'm sorry.
Does it include job history or just current job?
Right. So in the current data set, we have their current jobs, but there is the ability to gain access in the future with job history. So right now, the only thing that we get from stepping blocks is their most current position, but there is the possibility for more in the future.
And there's a question: how does this data differ with EMSI data? I'm not really familiar with it.
MZ? Yep. So I think it's very, very similar to MZ data. I've talked to MZ many times and we've looked at their data, and ultimately we decided to go with stepping blocks instead as our data partner on this stuff. But from my analysis, they're very similar.
As you can tell, my dog is interested as well.
Do we have other questions?
There was a question. Do you have any strategies or insights for investigating smaller within institution units like departments or small colleges?
We do. Before I answer that, Natsuko, could you pop the final slide up with the questions and our email address and stuff? So in our Umetrics data, which is the core data that we get from our member universities, we do receive what we call sub-organizational units. So this would be the college or school levels. And then we have a data file called the award identity data, which provides the department level data. So we've combined all of that. So you can choose, if your university has multiple campuses, you can choose the campus that you're interested in analyzing. You can choose the school or college that you're interested in analyzing. And for most of our members, you can also choose the departments that you would be interested in analyzing.
Another question: have you tied bibliometric data at the individual level, and how accurate was the name disambiguation?
All right. So I see Natsuko nodding her head. So why don't you take that question, Natsuko?
We have a faculty member who's the expert of disambiguating individual names and have worked on millions and millions of names using PubMed, Web of Science, and now I think moving to Microsoft, what was that?
Academic graph.
Academic graph. So it is pretty good. We have a pilot data set shared with a group of researchers, and they are successfully using the individually disambiguated name author level linkage work. And people are even drawing a network across like a citation and patent and all that. Very good question.
I believe we've addressed everyone's questions here. And
okay, great.
I'm mistaken.
So
if I missed anybody, just put it in the chat real quick or email us at the address on the screen or in the chat.
Yep. And I will say, if you are at a university that is an IRIS member and you want access to this data, let us know. We'll make it happen. If you are not if you're at a university that is not an IRIS member yet and you're interested in your university joining us, by all means, reach out to us and we can talk about it. We are very open. And I want to say that IRIS is an academic organization, and our board of directors is made up of university members. So they are elected from across our members. So decisions and everything are done collectively, cooperatively across all of our member universities. So we are there to support you in any way that we can. Yep, and I saw a question pop up. If they weren't a member, can they gain access to the data? So if you're not at a member institution, you can still gain access to the de-identified data set, but there is a seat fee involved with that. Is that correct, Natsuko? Yes, okay.
It's $1,250 for faculty members and $625 for graduate students or any student.
Can Stata be used with the data? Yes, we have Stata in the enclave. You can use that.